we see the relationship between blockchain and Web3, right? I'm going to try as possible to break down all of the concepts that relate with what was the existing system before the advent of Web3 and blockchain, right? So I'll give a little bit of introduction. I'm Dave, and I'm a coordinator and instructor here at Local Web3, and our research center, what we train and equip people to do skills to become Web3 engineers, right? So I'm very glad, I'm very excited to also be in this journey to guide people on how to become proficient with data querying skills, right? So yeah, all of this will not have been possible without the support from the Dune company, right? So the giving the go ahead so that we can actually do this in partnership with them. Yeah. So I think before we start, there will be kind of like a little bit of introduction and definition of certain technologies, right? So if you're lost at any point, please feel free to draw my attention and ask questions. So one of the things we're going to be talking about is the advent of the web, right? I mean, of course, know what blockchain is. If you know what blockchain is, can I see your hand? If you know what blockchain is, can I see your hand? Can you see my screen? If you can see my screen, let me know. Can you see my screen? Yeah. If you know what blockchain is, let me see your hand. Or if you don't want to, you want to try it? Sure. Yeah, sure. We gave it a shot last time, right? It's just
I think blockchain, right? I think blockchain is the connection of some of the cryptocurrencies or digital currencies that we have. That's what I think.
Okay, so I think we tried, but to give a little bit of introduction, it's better for us to know where we're coming from and what blockchain is all about, right? So we're coming from a situation where data storage, right, was centralized. Data keeping system was what? Centralized. So however, it's about data, right? So let me give you an instance. Let's say we have a class, right? A typical Nigerian class has a system. What's the system? In that system, we have what? We have an attendance registry, right? So let's say this is serial number. Have 1, 2, then we have like 3. It can be as much as the number of people in that class, right? So yeah, this serial number depicts a given row, right? So that means data will be entered for each row. Each entry to capture an attendance register. Yeah, right? Right? I want to get a reg number. Not necessarily. Okay, fine. Subject. Then probably sign. Timing, let's say timing, right? Then timeout. Then there are signature, right? Something like this. We all went to Nigerian universities, and this was the order of the day. For most of the classes that we attended, I don't know if I'm making sense. Is this okay? I don't know, guys. So let me know if it's fine. Which one is better? This one better. Is it better? Is it better? Okay, it's not better. It's not. Okay, this is better. So yeah, in a class and in every given subject, we had instances where a class monitor issue out what? And then that register. And the class monitor or the course rep, as the case may be, is working very closely with the lecturer for giving course. So now what they are targeting is the attendance of every student. Most institutions have specified in their when you matriculated that you must attend more than 70%. Am I correct? 70% upwards for you to be eligible to write exams. That is the standard in Nigerian universities. However, the approach for achieving this is very primitive because it is relying on an inefficient record-keeping process. So what is the process in this case? The person that is supposed to teach is relying on the students to what? Give them what? Attendance. So typically you have something like this for each course. So what are they saying? For each class, every a register will pass around, you come in, you sign in like that, you something like this. Basically, we know what I'm saying, right? And this kind of like is inefficient. So let's just populate this register with some data, right? Let's say this guy's name is what? Ahmed. And his thread number is what? 0010. And his timing is what? 0900 in the morning, right? Then he signs, right? Right? Let's say Elsie. Then she's 000, let's say 1. She came in by what? 0901, right? And she signs. Can you see that? This sheet of paper is what is holding custody of the records of the people. So let's talk about the inefficiencies of this approach. With this, we're able to define what the blockchain is. One, this attendance register, let's call it attendance register because let's say attendance register, right? What is the inefficiency of this attendance register? First of all, it is what? It is not secure. Why? Because the person writing here may be on his way home, accosted by what? Criminals. His bag stolen. His bag is containing the what? The attendance register. What happens? That record is what? Lost. Two, there's another instance of what? Theft. Sorry, another instance of what? Damage or fire or rain. We have instances where we don't know that this rain and we're on our way. Something happens and we are drenched, right? The book that we have written that attendance register is drenched, probably by rain. What happens? That record is what? Lost. Fire inferno. What happens? There's an outbreak of fire in the person's house. What happens? That record is what? Lost. It's not what? Secure. It's from one hand. Two, this record, what's it prone to? It's prone to what? Modification. The person in this case holding custody of this attendance register can decide not to. This Elsie, I don't like her. She did not greet me the last time. And you what? Come here and what? Wipe my records. Right? At the end of, before the exam, few weeks, Elsie will find out that she does not have any what? Record. Or for the assignments for the whole semester. It happens, right? The malicious entities as course reps in universities, they do that, right? Probably one thing happens and things fall out between Elsie and that person. What happens? Person just wipes the record and Elsie will be at the mercy of the lecturer, right? At the exam. And this is that is why this sort of thing process is what it's not secure. And what it can be what the record can be what can be modified. Modified or what? Tampered with. It can be doctored. She came in 9 a.m. and probably does not like that. It says she came in what? They came in 11. Happens. And they're taking for time of entry for giving class, and that makes her qualify for that exam. Then another thing that happened to this game is that it is controlled by a single entity. Record of everybody in the class. Let's say you have 100 people, right? Everybody have to what? Access the the good books of what? The class rep, right? And if you is not happy with you, will not show you. You'll be like, why are you not showing me this record? You say, yes, it's not really happy. It's not okay. Just hold on. I'll show you later. It happens, right? Like people like that. I had some instances of some course reps then in the university, right? So the access to this data, you at the mercy of what? The course rep, and it's good. It is not what? Open for everybody to access it. So it is what? Centralized. Then again, everybody is controlling everything happening there, right? Something's happening. For each entry, we're supposed to be, the record is supposed to be distributed. All of us are supposed to be seeing what's happening, right? You can actually say that's centralized and not distributed, right? Recording this attendance register does not spread. So for each new entry, everybody in the class is supposed to have access to that one register as for entry. Now, this is the problem, right? Then what I think another problem again with this attendance register? There's another problem. There's another problem with this attendance register. Data is not distributed, yeah. Not data is not what? Distributed amongst what? Class participants, class. Yeah, people, classmates. Yeah, this is a problem. Now, how do we provide information that addresses from this problem, right? Blockchain addresses this problem because we're going to talk about each of these factors that I mentioned here, right? So what is blockchain? Blockchain is one, secure. What is the security of blockchain? The security of blockchain is guaranteed by what? The cryptography, which is the core hashing algorithm, right? Implemented to secure what data. But don't learn about that. Right? Every record on blockchain is what? Guaranteed to be what? Secure because of what? The hashing cryptography mechanism by default adopted by what? Blockchain. Two, every record cannot be what? Tampered with. Cannot be, it cannot be tampered. Every attempt to tamper the record is also a record. That is what? That is stored on the blockchain. Everybody is seeing it. If you want to tamper something, it's also an instance of an entry on the ledger. Then the next one is what? It is not what decentralized. That means this ledger is not controlled by a single entity. The death of your classmate, God forbid, is the end of the what? Attendance register. That's in there. Attendance register. Does that make sense? Yeah. Yeah. So blockchain solves that because it is not what centralized. It's not controlled by that entity. It's not made by the goodwill and mood of the what? The class rep. So blockchain addresses that. Then probably the fourth thing, sorry, every entry in this record, in this class registry is what? Distributed. What does that mean? Please let the distinction between distributed and what? Decentralization. Decentralization means not controlled by what? A single entity. Hope you know. Decentralized means it's controlled by all the participants in the world, in the class. Everybody determines what happens. And it is not really relying on a single entity. One entity cannot say, you know what, it is over. And everybody will say, it's over. No. That's centralization. Then distribution. Data distribution means the spread of data, right? How is each entry accessible to all participants in the network? So we're not learning about nodes, right? Every node is connected to another node. So the information, let's look at it as this, right? I have a computer. This is my node. The information on this computer is spread. Anything that happens on my computer, your computer knows about it. All of us were here with our computer, right? The computer knows about it. The computer knows about it. It's kind of like a gossip, like right, like that. Every one of us have for LC that was entered to spread. This one comes to this one, peer-to-peer network. Everybody has a copy of that one. And does that make sense? Yeah. So that's that. So this is what blockchain is all about. Blockchain is what? We can actually say that blockchain is what? A secure, tamper-proof, decentralized, distributed what? And permissionless what? Ledger. So let's so we understand this attendance right. So I just use this as an instance to describe the inefficient approach of writing records in a piece of paper, right? And we talk about all of the issues that's kind of like associated with this approach. Now, what is blockchain? Blockchain is what? A secure, tamper, proof, right? Decentralized, distributed, and permissionless. So permissionless in the sense that you don't need access to, you don't need the permission of any entity to access records. So all of these will actually say it is what? Secure capital centralized distributed permissionless what? Ledger. So what's a ledger? What's a ledger? A database, anything like that, where you keep records, basically. So that is what we're watching for a while. So we're going to see how it relates to what we're going to learn today in the course of moving on to the history of Web 1, Web 2, and Web 3. Please, on one hand, note this is what blockchain is all about. Does that make sense? So this is blockchain. Then we're going to talk about the web. So please, note this. This is just something I want you to note, right? So let's talk about the other hand. The other hand is what? What's on the other hand? The web. So we have Web 1, Web 2, Web 3. So everyone's saying Web 3, Web 3, Web 3, Web 3, Web 3. Who can tell me what Web 3 is all about? I know we want to look at it, but don't look at it, but it's very hard. Just see what it's saying. Right? Yeah, sure. Awesome. So that means for you to say Web 3, that means there was what? Web 1, and there was Web 2, and now we're talking about one, Web 3. So we're going to talk about what each of these technologies talk about. Web 1, just read. You read on the internet. Read, just read. You don't have to write. Just read. It's just like a go-to place where, how would I put it? You can't write. It's just like Wikipedia. It's what? Wikipedia. Yes, Wikipedia. Wikipedia, or remember when we're growing up, right? Students have no access to what? Write on notice boards, right? When they write and they publish their announcement, they lock it with key. And it's a glass, unless you want to break it and tear down the place. It's just read only for what? The students, right? We all came from schools and we know how this approach is. You just go to the notice board, oh, exams are certain, so faculty exams are certain. That's how we know exams are going to start. So, of course, I'm making sense, right? So you have no power. Even if you go and write, it does not hold authority. If you go there and fix anything, it is not the school stopping, it is you. Right? So that is just an instance of what was happening before Web 2 became a thing. It was just a read-only. The internet was just about reading only, just read only. Right? Now, transition to what? So this was before the advent of what? Facebook and other social media platforms and the big tech companies, right? Google and all of those, right? Became a thing. Before then, you just go to the internet, and the internet was very ugly. Right? Just HTML, no CSS, no styling, just come there and very, very ugly stuff. You just read from the web. Now, what has happened? There was an inefficiency of that approach. That was why people were like, how about we give people access to kind of like to their data, right? But in this case, can create a profile, kind of like publish that profile. That was what made Facebook so popular, right? Students in the university could like have a profile, post, like engage in those posts, kind of like what social media. So the island of social media, actually, right? So what gave people that ability to read and write and modify the internet, and in a false sense own their data. In a false sense, because then when Facebook became a thing, then to blew up in Africa, I was very much around 2009, 2010, right? Everybody wanted to, anything you're doing, you're going to church, you're schooling, you're going to like what the English you want to like put, then they drop this one here. Some of us did it. Some of us did it like, right? Let me post this one here first. Yes. Yeah, and you post your view, you post your new blog, like you want to show off, right? So yeah, so what started happening something started happening because after a while, people's accounts were being deleted. You thought you owned this account and you've been uploading a lot of stuff on the internet. All of a sudden, for you to wake up one day, you're trying to access your account, they said you violated some community guidelines and you've lost access to what? Your data. And all of those pictures you've saved, what happened? Facebook, I thought they have your account. You've lost access to all of those pictures. Does that make sense? Yeah, so that was what Web3 was all about. Companies like Facebook, Twitter, all of these big social media giants, every to keep sense of what this is the if you claim you own, what happens? What money block your accounts? Your account is gone. Now, some people are like, there's blockchain already, right? How about we leverage blockchain to give people access to read, write, and what? Hold their data. Hold your data. If you deploy any application on the blockchain, right, and you have a front end that is reading from that blockchain, right, what happens? You will never be censored. So look at it this way. The typical database architecture, so the typical web architecture, have a front end, right? This is your computer, right? You have this is a computer, right? This is your front end. It's talking to a what? A server. This server has the database and all of that here. Then let's say you have the database. This is the backend. So let's see. Right? So you use your backend server and reading with any language like SQL, you have the database, Postgres, MySQL, like that. And the cloud to architecture, right? Where you, as probably you are leveraging this architecture, right? And your server is hosted somewhere, right? This server and your backend as your database, right? The server and database constitute your backend, right? And this is hosted in AWS, Azure, or any of these cloud services. Now, what happens if that data in this space is taken down? Right? Probably AWS is attacked. What happens? What happens? All of that data is what? Lost. This is a typical way of what? Architecture. This is what to architecture. Because what companies like what? Facebook, Twitter, this is what they leverage. So you create an account here, you send it to you on your front end, right? Probably when you violate their rules, you take whatever you populate on the server down and you cannot access it again. Now, this is a primitive architecture because you don't want data. They give you a sense of false ownership, right? Because whenever they have your account, all of those things you see, let me post this one here, and you've done it for like 5 years, all of those pictures can't access them anymore. Now, Web3 is leveraging the security, the tamper-proof, decentralized, distributed, functionless nature of what? Blockchain, to give people back their ownership, right? So before we talk about this, who knows what Bitcoin is? Bitcoin was the first instance of what? Please, I will follow you. If you're not at any point, please call my attention. I will give you a quick rundown of anything that is not clear. I'll go over it again so that we're all carried along. Now, please remember, I started by taking, let me recap. I started by talking about what? The inefficiencies of paper databases, in this case, an attendance register, which is what we all experienced when we went to universities, high school, secondary school, post-college high school, with post-secondary school here in Nigeria, right? So basically, this was the case. And then I gave an instance of what characterized the record keeping process. We said it was what? Once you clear all of this, then blockchain can solve it. Then they talked about what? The advent of what? Web 1, Web 2, and 3. Now, I've talked about blockchain, I've talked about Web 3, but I'm going to come back to Web 3. Just follow me. Now, blockchain was never powerful until a platform called what? Ethereum, big platform. I'm coming. We'll get there. But how many folks have heard about Bitcoin? Bitcoin, we all know Bitcoin, right? Not the cryptocurrency that we go to trade on Binance and we get some benefits. Because we're having a grow now. Probably first was $90,000 and $100 and you play some games. Think about technology. Now, there was a global financial meltdown that made some group of persons, not just one person, right, to begin to rethink money, right? And this group of persons came up with a slogan, what? Satoshi Nakamoto. Under the slogan, a false name. This group of entities, right, referred themselves as what? Satoshi Nakamoto. And they wrote the Bitcoin white paper. This was what really bettered modern day blockchain. I don't want to go into the history. A lot of people have written some such papers before Bitcoin became a thing, right? But we would almost give kind of like the chronology of what happened, who wrote what, who did not write what, which paper was there, which one was not published. No. This was the template for the modern day blockchain. Are we together? The Bitcoin white paper set the tone for modern day world blockchain. So what is blockchain? As proposed by what? Satoshi Nakamoto. In his own sense, it was Bitcoin. So they were proposing what? A peer-to-peer what? Version of what? Electronic cash. That would allow online payments to be what? Sent directly from one party to another without going through financial institutions. So they wanted to eliminate the interference of financial institutions in what? In payments. Right? So people can learn from person to person, P2P. Right? I'm going to talk about this. But Bitcoin was primitive in its approach because the approach was about what? Payments. The first instance of blockchain was about what? Payments. They wanted to remove third parties. In this case, financial institutions and what? Banks. And that was what Bitcoin solved. When they released this white paper, Bitcoin, they said transactions were going to transact from person to person electronically, right? But there was a problem. You cannot leverage this technology to build stuff. It's just for payment. It's a primitive blockchain. So if I send money to you, so what Bitcoin basically is tracking as a blockchain is what? UTXO. Unspent transaction what? Output. If I have 5 Bitcoin and I send you 1 Bitcoin, I'm supposed to have what? 4 Bitcoin left. And you, the basically, are supposed to have what? 1 Bitcoin. And if you cannot spend more than what? 1 Bitcoin. You can only spend lesser than or equal to what? 1 Bitcoin. Does that make sense? That's what Bitcoin as a blockchain is all about. So let's go. Digital signatures provide part of the solution, but the main benefits are lost if a trusted party, third party, is still required to prevent double spending. So it was eliminate what? Third parties and what? Prevent what? Double spending. So if I send you 1 Bitcoin from my 5 BTC, I cannot send that 1 Bitcoin again. So I can only send what? 1. So remove unnecessary what? Third parties, prevent what? Double spending. There are instances, I've had instances where I transferred money to somebody, and so for instance, let's go back to a typical banking application, right? If I have 50,000 in my bank account, and I send you 10,000, and my balance did not go down to 4,000, what will happen? I'll keep spending. I will spend the money. If that's the typical Nigerian talking, he will spend it, right? So 50,000 he will spend. He will send to 200 people, and you see 50,000. You're a rich man already. 2 of us, you're double spending because it is a failure on the end of the server to know what accumulate each of those 10,000 cents per time. So that's a double spend. If you spend 10 out of 50, you go to what? 40. But if you reflect your app, it is what? It's what? 50. So that means you can send to multiple persons and your balance will not go down. This is what we call double spend. You're spending the same amount of money and that is not actually capturing the balance. So that is an instance of what? double spend. That is one of the things Bitcoin was going to solve, right? The problem of what? Removing financial institutions and what? Prevent what? Double spend. So how is it going to do that? It's going to do that using what? Digital what? Signatures. Please bring this Bitcoin white paper. I'm not going to go into details, but this abstract covers one of the things that set the tone for modern day one blockchain. However, when Bitcoin was very bullish about removing third parties, preventing double spending, enabling people to kind of like leverage a network transaction by hashing them. So we're going to learn about these things because this is what better what cryptography, right? We're going to see how cryptography is used to hash transactions in the block. This is what all the blockchains are using. This set the tone for cryptography in blockchains. I hope that right. So yeah. Then when this happened, remember Bitcoin is just tracking payments. But there was a problem with Bitcoin. It's just payments. How about we want something that's also payments and also allow us to, instead of hosting our server, because this server cannot keep it to your computer. If you put the backend service, you have Postgres running as a database, and you have what? Probably Rust or Adron framework running on your computer. If you make the request of that server, and for instance, probably somebody comes to shut down your computer, what happens? All the requests will not be going again. So you need to what? Host the database on a what? And your server on a what? On a cloud service like what? AWS, GCP, and Azure, or Render, or digital ocean education will be. Are we together? So this introduces a centralized approach because what happens if this cloud hosting service you're hosting your backend goes down, right? The thing was like, there's a problem. How about giving people to what? Compute on the world computer, hosting, instead of hosting this thing, this server on AWS, how about you host it on what? A service that is what? Decentralized. And that was what better the what? Ethereum. Does that make sense? The efficiencies of Bitcoin to enable people to build stuff on it was already better than Ethereum. Ethereum came up with, okay, Bitcoin is doing this, how about Bitcoin come up with, okay, anybody can actually write anything and it's saved as a what? A contract on the blockchain. I'm going to talk about a smart contract. That was what created smart contracts in Ethereum. So now, I write my backend server, instead of writing backend, front end, blah, 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 I just come here and write what? Solidity. Using Solidity, I write what? A smart contract. And I deploy it to what? The EVM. This thing, right? This is my smart contract. My front end will just connect to my smart contract. Automatically, this on Ethereum. I don't need all those architecture. Automatically, this on what? On Ethereum. So that makes sense. Hello. So this, as far as Ethereum blockchain is running, your record cannot what? Be removed. Does that make sense? That's backend service. Let's say, for instance, I want to build an attendance register, right? Somebody comes in, sign out, all of those things. I write a smart contract with Solidity and deploy that smart contract on Ethereum, right? Ethereum came up with the idea of what? Smart contract, what smart contract, right? Just periphery, then we move away from that, right? So that we're actually focused on. We're not come here to make you smart contract developers. We're going to write Solidity, no. You just know about structure of a smart contract, know what you can actually listen for that's happening on chain, and kind of like based off those event emission from that smart contract, build amazing product. That's what chain is all about. Does that make sense? Hello guys. Are we together? Who is not following? Please ask your question. You look lost. You guys look lost. And also for people who are joining us virtually, can they ask? I have a question. Somebody wants to ask. Any questions so far? So now, this is what Ethereum came up with. So you connect your front end if you want, a smart contract, and that smart contract is, as far as it can be deployed on Ethereum, it is what? It's not proof. It cannot what? Basically, it will run, and you can actually just from the front end calling that smart contract, and keeping data, writing data to it. Basically that. And this is not controlled by a single entity. As far as it's on chain, nothing will happen to it. Is there any question?
Yes, sir.
That is your question.
Okay, for the purpose of understanding what blockchain is,
Yeah.
Okay, can you give us examples of blockchain? It's a process of constant.
It's a one?
Yeah, like since the definition of the blockchain has been given, like example of blockchain, these are. Then if you get that.
Come again, I didn't get you.
So, with what you've said so far, blockchain is a ledger, right?
Yeah.
So, can we have examples of blockchain?
Oh yeah, very, very good. I get you now. So yeah, so I think we will if I answer that question, because we're trying to like balance it, and we'll be looking at blockchain and different instances of what blockchain. Like I mentioned, the first instance of blockchain that became very popular is what? Bitcoin. So Bitcoin came up to track what? Payments, P2P payments, removing the need for what? Trusted third parties, and what? Preventing what? Double spend, guaranteeing what? Digital signatures, using what? Cryptography. Does that make sense? That is what Bitcoin is all about. Please, when you're going to read Bitcoin white paper, very, very important. Going to have you understand the concept of blockchain. Now, Bitcoin was a primitive approach in that it did not tackle the problem of what? How can we deal with this as a developer? Bitcoin is just taking payments, right? And because of that, UTSO, like I mentioned, unspent transactional output, I send 5 BTC to you, and I have 6 BTC. I have only 1 BTC, right? I have 5 BTC, I send you 1 BTC, I should only have what? 4 BTC. Unspent transactional output. That means I can never spend more than what? 4 BTC because I've sent 1. That's what unspent transactional output is all about. And you, as recipient, you can never spend more than what? 1 BTC. Does that make sense? You can only send lesser than 1 BTC. You cannot send greater than the balance of BTC you hold. So that is what Bitcoin is only tracking. Payments. Now, another blockchain came up with the idea of what? Smart contracts. Ethereum call this a what? Please let me clarify. What's Ethereum? Please can you read the first statement? Is what? Thank you. So what's a word computer? What's a computer? Please let's talk about the computer. How about computer? What's a computer? It has what are the main components of a computer that makes a computer? Storage, processing and what? Storage, processing and what? Memory, right? ROM, RAM, and processing. So everything running in your computer now is managed by what? A process targeted by, you can target the process ID and kill that process. If you kill that process, that thing will stop working. Your browser, everything that you're using now, like making your computer work, everything is managed by what? A process. So if you target that process ID, because an identifier of a process, if you kill that PID, automatically that thing will stop working. If I kill the PID, that's the process ID of your browser will stop working. If your browser is listening to a particular port, right, managed by a process on that port, automatically that browser will die. All the things you have run that on your different tabs. If you're coming and you kill it, automatically that process and all the things that is running dies. So a computer has what? Storage, right? ROM, RAM, memory, and what? Process. How does it? Are we together, guys? Yes. Are we together, guys? Yes. So tell me, saying, I am what? More computer. Instead of us to be having our respective individual computers. Why don't you have a one computer that is managing all of the things that the computer is all about? So instead of you to write stuff like this, right? The backend deploys on Azure that is centralized. If Azure goes down, or Google GCP, or AWS that is hosting your server, what happens? Everything you have deployed is one gone. Instead of saying, let's just build out those computer, let's just build that hosting service that can actually perform what? Read and what? Writes. So you write a logic, you try to work as a contract. That contract, so instead of oh, we know that when we write our backend, we're writing the language, right? Whether JavaScript, or TypeScript, or Go, Rust, it is you are going to have a server that's going to be listening for what requests on different endpoints, right? And all of those requests on the different endpoints going to be connecting to a database. That's a typical web architecture, right? I don't know what some people call it true layer, single layer. It's not our problem. But just giving you an overview of what happens in typical web architecture, right? Instead of saying, you know what, we don't need this guy, we need the Web 2 approach. How about we have write a smart contract in Solidity, right? Deploy it on what? On Ethereum. Ethereum will run it at the service. All you just need to connect your front end to one, the EVM, as far as that contract has been default. It cannot go down. That is what Ethereum is trying itself as well. You want to do that. So yeah. Any question? So yeah, so I know there are questions. Let me talk about that question. Okay, so let's talk about the components of the transaction, because at the end of the day, remember that record, all those flow, 1, 2, 3, are what? Are what? Transactions. There are data, yeah, there are entries, there are data records. There. Each entry, each row is an entry. True of course, you're coming from SQL, you know what I'm saying. You create a table. The table is containing what? Columns and what? Rows. Each row is a reference of an instance of an enter data to what? Of course. Am I making sense? Thank you. I'm talking to data people, so we are not lost. So we know what I'm saying. Right? So what happens? Each of those rows, on Ethereum, it is called what? A transaction. So let's describe it. Hope you understand this architecture, because we're going to come back to it later. Do you understand? Now let's go. Is it fun? Are we having fun? Please, you're having fun. Let me know. Are we having fun? Let me hear something positive response. Are we having fun, guys? If you're not having fun, that means I will assume you had a lot of things. Are we having fun? Let's go. So let's talk about each record. Each record in the row. Row 1, row 2, row 3. In the blockchain, it is protected. So what is a blockchain? We just define the overview of how blockchain is treating what? Records as a ledger. Does that make sense? We're going to see it real time. So what is block? And what is what? Chain. A block is a collection of what? Transactions. How does it relate to that person in time from that description I showed you earlier? Now, remember, this is our record, right? I have 4, I have 5. Two of us have this. Now, in blockchain, please follow me. I know you're going to be a bit lost, but I'll make sure I get you. Now, we have what? Block. In blockchain, it's an index-based system, just like the regular programming, right? In an array, just an array is your zero index based. You cannot say it's starting from what? 1. It's starting from what? 0. In the same way, we have what? Block 0, block 1, block 2. Then here, let's take out one block called what? Block 3. Please follow me. A block. What is a block? A block is a collection of what? Transactions. So let's divide this block. So we have what? T1, T what? 2, T what? 3, T4. Yeah, let's do. All of us are going to come to this board and we're going to showcase that we know what I'm describing. So please, do along. Now, remember, we mentioned cryptography, two of us. Each of these records is a simulation of what? A transaction. So comparing a typical record of Ahmed, LC, and then any of you here, Hassan, right? In the blockchain, let us assume that this is a block, and each of these records is simulated as a what? A transaction. T1 capturing the record of what? Ahmed. T2 capturing the record of what? Hassan. T3 as this may be. Do we understand? Yes. Now, how is it secured? Now, it's using what we call what? Hashing. There's a hashing algorithm linking each of the what? Transactions together. T1 we hash plus it will hash and T2 hash of T1 and T2 will give us what? Hash 1. Hash of T3 and T4 will give us what? Hash 2. This is not all. We will further hash. Hash 1 and hash 2 will hash give us what? No, a root what? Hash. Yeah. A root hash or make root, any one of them, anyone depending on the blockchain, anyways. So this is the reference that every block have their characteristic what? In your head, they have the characteristic what? Hash number. Hash number. Right? It is hash. Every block is what? Hash. What is a hash? Who can tell me? A hash.
C'est hexadecimal system of coding data.
Very well. A hash means, let me, please, we'll come back. Hope you understand what's happening here. So let me use here, right? Let's have this hash function. Let's call it what? A hash function, right? It takes the name what? Who's interested? Hassan. I like Hassan. Others don't even know that they know that person. The hash of Hassan will always give you what? A deterministic output. Let's say OSE 1, 2, 3. This is a hash function. If you pass in the test, Hassan, it will always give you what? OSE 1, 2, 3. For instance, this may not be depending. They will have a lot of hash functions. We have SHA-256. We have we have complex hashing algorithm. But we're not going to talk about them. All of them will get something, and that is giving a certain input. It's going to give you what? A certain known output. The hash of Hassan, HASSAN, will always be what? For instance, OSE 1, 2, 3. It can never what? Change. Does that make sense? If I change Hassan what? Capital N, the hash 2 will change. OSE 1, it's not even the 2, it should be 5 or something. This is what gives blockchain the characteristic what? Security. We'll talk about that in relationship to this instance I'm describing here.
Okay. The question now, it means that nothing can move and no entity can move without touching another one. Right?
We'll get it. We'll get them. Yeah, you're very correct. We'll get them. Just follow me. So yeah, just follow me, guys. Are we together? So yeah, so look at it. If I have Hassan, HASSAN, it is not the same with what? N, small letter N. Every character in the that's an input, right? This is the output. Given a given input, it will always give you what? A known what? Output of each length and size. It is the same thing. Hassan was giving what? This hash. If I change any character, this is the input. The output will what? Change. Please, are we following the question? The what? The input is modifiable. The output is what? Known. you can never what? Change that output. Hassan, the hash of Hassan, anytime, any day, take it from here to New York and pass it to the same hash function. It will always give you the what? The known output. Does that make sense? Hello? Hello?
Input is modified, but output is what?
Yeah?
Input is modified.
Output is what? Known. Is deterministic. Deterministic, you see it most often in most blockchain resources you're reading. Deterministic means what? It is known, it can be known. It cannot be gamed. If it is this, it is that. It can never be changed. Right? So the hash of a given input will give us a what? A known what? Output. Now, how does this relate to what we're doing here? If transaction record of T and T2 gives us hash 1, that means anytime you bring this particular transaction, the hash is going to be the same, right? Hello? Passing the arguments of T1 and T2 into a hash function, it's going to give us what? A known what? Hash. In this case, hash 1. Passing input of what? 3 and what? 4. Transaction 3 and 4. It is going to give us a known what? Hash. Debuted as what? Hash 2.
Yeah. What if is it situation where transactions are odd? Because it seems like even they pair to themselves.
Good question. I'm going to come there. Yeah, we're going to do it. And all of us will do our own. That's going to be an exercise. All of us will come to the call and tweet it. I just can't see your nose. No, don't worry. We're going to tweet it because he said, very good question. He said in this block, the picture here, we're having only what? 4 instances of what? Transactions. Is it correct? Is it at the same time all of them are different numbers? No. We're going to cite them and we're going to learn about it. So yeah. So please follow along. If the hash of T1 and T2 is going to give us hash 1, T3 and T4 is going to give us hash 3, we're going to further hash it until we derive what? A root hash, the hash of the entire block. You understand? So this hash is what makes blockchain what? Be secure. If you tamper hash 1 and hash 2, it will never give you what? This hash. And this is why blockchain is secure. This is guaranteed by what? Cryptography, like I mentioned earlier. I said the security of blockchains is guaranteed by what? The cryptography it is using.
The structure against cryptography.
The security of blockchain is guaranteed by cryptography, yeah. So yeah, so that's really that. So now, how does it relate to what we're doing here? Block 0. T1, T2, T3. So we're going to say what? T1, T2, T3, T4. Like this. Right? Then this one gives us a hash. Remember, this one has a what? A hash. Right? This guy here, once it is derived, it is going to reference the hash of the what? The preceding what? Block. It must be part of the block header. We're going to talk about the content of the block. What makes a block a block? There's a block header and a block what? Body. All these things we are doing here is part of the what? Block body. But I want you to play with it, understand it so that it makes sense. Right? Are we together?
Sure.
Who is not following? So yeah. So we block 2. We have what? T1. So somebody come and hash T. I'll call you. I should not call you. You want to cry. Who wants to come? What if all volunteer? Just come and see how we're doing, right? So T1, T2, T3, T4, T5. Who wants to hash this and then give us the hash? Oh, just try. Just try. Yeah, sure. Come on, guys. Remember, we asked the question, must it be even number? In the case we have odd number transactions in block. Hash it for us. Yeah? Yeah? So what happens to this guy? T5. No. Look at that. What happened? Hash 3? Yeah, it's correct. Hash 3, right? Hash 3? What happened to it? You're correct. Very correct. Continue. Thank you. Actually, yeah, nice. So other hash again.
Okay.
Very absolutely correct.
Second hash.
Yes. Second generation hash one. No. Hash one.
Okay, okay.
Yeah. This one.
Hash one.
And this one. What? This one will further hash again because to have this
Okay.
hash 3, right? So we're going to have this hash 3 again here. So it's going to be hash 2. This one is going to replicate itself. Does this make sense? So that we have this odd number. Look at what things are. This T5 in the sense will be T5. We're going to have what? Please follow along that. T5 and T5, we're going to have the replicate itself to give us a what? A single hash. Now we have this one and this one will pay and to give us this. This one we pay again with another one to give us what? So yeah, so let's say hash 3, I will have what? Then this hash 3 got what? Apply to any odd number to the right bits. Hash. Yeah, that's how it works. This is how it works, yeah. Whether it's 20,000, 19, 18, the principle is the same. If it's odd number, the odd number, the remaining one will hash again until the further hash to match the root hash. Right? So you have to do that. That's how it works.
The odd number, the hash itself.
Will hash itself, yes. The odd number transaction will hash itself.
Okay.
First generation hashing, second generation hashing, final generation hashing to write the what? The root hash.
Okay. What does odd number transaction means?
Very good question. The number of transactions that we're able to what? Be aggregated within the time slot given to a miner on Ethereum, right? On Bitcoin, they're called what? Miners. Miners are machines running as nodes that can kind of like go through the mempool to search for what? Transactions. Remember, a block is a what? What's a block? So people have incentivized to go to the mempool to aggregate what? Transactions. If they form a block that is valid, and other people attest that that block is valid, he will gain some reward for mining that block. Mining is money for Ethereum, for block for Bitcoin, very profitable. That's if you have the computing power, the computing hashing power, right? It's very, very competitive because everybody's trying to like this is a rat race. Who will win? Like everybody's trying to like also, hey, who will be the person? Transactions are happening, so everybody's counting who is going to go aggregate transaction for the block. If you do that and you have a valid proof that everybody can say, yes, you did the proof of work, right? That is, we're going to talk about consensus algorithm, right? Consensus algorithm, how are these blocks aggregate, how are these transactions aggregated to form blocks? Is it that anybody can just form and just carry anything and put there and it will go away? There should be some form of proof, right? Yes, that's what we call consensus what? Algorithm. Who are the people in the network that will determine that this person did a valid work to constitute this block containing all the transactions in the network? So when you send the transaction is not immediately added to the block. It is in a waiting area called what? Mempool. What is mempool? Memory pool. A temporary holding area for transactions. So it is, if it is Bitcoin blockchain, miners will go to the mempool and create transaction. Solve the puzzle. If they solve the puzzle of nonce, number used once. So this is the difficulty. Like if they solve it and that nonce is valid, right? Every miner acknowledges that this nonce is valid. That block is what? Added to what? If they mine this one, it will be added here. So like that. That's why it's a blockchain. It's always appending to the last block. Appending, right? Your nonce is valid if the network acknowledges it. And so that means if consensus what? Algorithm. Called in Bitcoin, it's called what? Proof of what? Work. Proof of what? Work. Consensus algorithm. That means everybody will say, yes, this man true. He did the true work to result to arrive at this what? Block. As such, all the transactions in that block are what? Valid. Otherwise, it will be thrown away, it will be discarded. And the person that really did proof of work. So if somebody wants to maliciously create a block it will be discarded because it's not their acknowledged in the network because this consensus is reading. Who is this man? Or Joroman, an INEC official. Professor Jega, sorry, you know the people that funded us. They scammed us. They want to say 1 + 1 is 20. And it's a lie. In blockchain, consensus algorithm will say, no, this block is invalid because it did not do the appropriate work. Right? Tonight they want to call what? A nonce, number with ones. That's what everybody is solving as a puzzle. If your puzzle is valid for Bitcoin, then that nonce is valid and everybody acknowledges what's known as valid block. Otherwise, that block you create, you just wasted your time burning your computing power and internet and money because you need to pay for Starlink. Right? If you are a miner, you can be a miner from anywhere, right? And people are mining in this arena. People are mining everywhere. You can actually mine if you have the computing power, it's also used. You can actually do that full stop, basically. Right? But you need very high computing power because it's like somebody racing a Ferrari with a Beetle. If your computing power is very poor, the Beetle man, the Ferrari man will get to Lagos with Abuja and chilling. He has taken his bath, eating. He has gone to chill with his friends and watch ball. Then the Tuke man, the man with the big suit, is coming to come back. So that's how it is. So in the race to constitute blocks, you must have solid what? Machine with high computing power. Right? Otherwise, you will be playing catch up because you are just wasting your time. Just shut down and want other people to the tail. Right? So yeah, that's why. So on Ethereum, it's called what? Proof of what? Stake. We're going to talk about that later. But I want us to understand this concept. Right? So somebody should give us an instance of a 7 transaction block and hash it for us. And let us drive it. Who wants to go?
7, right?
Yeah, 7.
I want to go.
You don't want to go. I want you to go. Ladies. Ladies first. Ladies first. Yeah, let's see. Let's see how you do like that. Our audience, are they following? Please confirm. If you have any questions, please.
Thank you very much. I hope you guys are enjoying the session. And please, I would like to say something before we continue. Please follow Blockheader Web3. They are a Web3, they are a Web3 research institute. Follow the Buildo and please follow Dun Africa. And please screenshots, share it on your social media so that everybody can know that this is happening. Thank you very much.
Yeah.
Yes.
Nice. Nice. Yeah. Then the further one, hash. Nice. Yeah. Nice. Let's talk about that. Now, listen, simple. So, is the consensus algorithm behind all of this? The same principle. It's a protocol. All rules, right? On Bitcoin, there's a rule. Each blockchain. So, see, ask the question. I'm not debating on that question. I just give this and I actually have a broader view of how we translate what happens on the board, right? What I did on the board with the attendance registry on the blockchain. This blockchain was records. Every message you send a transaction probably from person A to person B as is entered as a what? As an entry. So when you send that transaction, the transaction will be on the main pool. Then if it's on Bitcoin, miners will what? Aggregate that transaction to become a block. If it's on Ethereum, validators will what? Be selected randomly to aggregate that transaction from a block. Now we have so many instances of what? Blockchain. We have Bitcoin, the first instance of modern day what? Blockchain. Although there are research papers, you see that there were other blockchains before. People are looking at that proof of concept, but Bitcoin was the first working tool instance of blockchain, written by what? That became what it was. Right? Then another blockchain came on board, which is what? Ethereum. Ethereum, as a matter of fact, the founder of Ethereum was working for Bitcoin, right? He saw the problem and proposed it as a solution. But the Bitcoin guys, not to say this against that community, they said no. It is casting through. We're not going to improve it. This is leave it as it is. The old way is the best way. That was one brought about what? Ethereum. Peter Leak was an author in the Bitcoin magazine. He proposed this and it was rejected. Then he came up with his own idea with Gavin Wood, the founder of Polkadot, another blockchain. Right? Gavin Wood was a doctor and a researcher. Right? They teamed up and formed what? Ethereum. They wrote Ethereum yellow paper. Solidity as a smart contract running Solidity as a smart contract language for running smart contracts. Yeah, so that's basically how Ethereum became. Then after a while, the Wood proposed something. He felt Ethereum was not doing it, and he formed his own blockchain called what? Polkadot. That is it. So we have so many instances of blockchain. Solana, Cosmos, all of these guys, but they are all using the same principle. Transactions are sequenced like this in blocks. Block and there's a chain. They are all linked. Blockchain, they are linked. They are linked. A given block is linked to the preceding block, and they are all the hash of this block is referenced. The hash of block A is referenced in block B as what? Parent hash. Does that make sense? So anything you agree must reference your that where you're coming from, so that it is linked. There is no what breaking rule. Nothing will break. If the hash are not matching, then you cannot enter. As determined by what? Some rules. In this case, what? Proof of work for Ethereum, that's the consensus algorithm. And proof of what? Stake for Ethereum. Are we together, guys? It's not like anybody can just come and be doing this thing on their own. First of all, you must have a machine called what? A node that will run the software for you to implement adding on blocks to the network. Does that make sense? Yeah. Any question, please? I want questions. You guys are not asking questions. Please, the question.
So I don't know if it's not just doing that.
So what?
I don't know if it's not just doing
No, please note this. That's a very good question. Adding a transaction. Let's go together. Let's do something. All of us go to metamask.io. How many of us have metamask? Metamask.io. Go to metamask.io. So download what? An Ethereum wallet. We're going to see how it works. Does that make sense? So let's go. Let's do something. Let's go to a block explorer. etherscan.io. Let's go, guys. Are you there? Are we all there? Go to etherscan.io. So let's see what's happening. So this is the block explorer. What's a block explorer? A block explorer is a page where you see all of the blocks, all the transactions and all of the blocks. Please note this. Transactions aggregate to what? Form a what? Transactions aggregate to form a what? Transactions aggregate to form a what? Thank you. A block is a container holding what? Transactions. So if I send it from my wallet to his wallet, or I send a cryptographic message on the network, all of these things are what? Entries of data that is temporarily held in where? The mempool. Now, a validator will go to the mempool, aggregate all of those transactions until the max gas limit is reached. So I was expecting this question. He asked it, but he didn't ask it well. What determines the number of transactions in a block? One, the block gas limit. On Ethereum is 30 million gas. Let's go. So let's look at this block. So look at it. So can somebody tell me what's happening here on this page? Tell me what you observed. So the block explorer is a visual representation of what? All the blocks and all the what? Transactions. So can somebody tell me what's happening here? Can somebody tell me what you have observed? What did you observe? I know, yeah, that's one. On this page, what did you observe? Okay, let me view all blocks. What did you see here? A machine is telling me But I'm human. Look at it, the computer verifying me that it's a human being. All right, let's wait for it to do that. So, there's a question. Left. Ask the person to ask me. Also, what's the question? Let me say, question. Who gets criticism of nodes? Who what? Gets criticism of nodes. The criticism of nodes. Yes, criticism of nodes. Like who gets it? Who gets it? Yes. Yeah, very good question. We'll come to that question. But before we do, please, can somebody tell me what you observed here? What did you observe? Just no, let me go back. This is kind of like more detailed and on to. So tell me, what did you observe here on this latest blog page? What did you observe? What did you observe? No, you're correct. What did you say? I said, what did you observe here? Let's forget here. We'll come to this one later. Thank you, but again, I'm going to a critical observation of the ID. The what? No, not every second.
Is it like so for the last ID one they say it was 4 days to 5 days?
Thank you. Please let's start for her. The minimum increment of the what? The block number. So this is block number what? 22,553,300 what? 54. It is going by what? 55, 56, 57, 58. If I refresh this thing, not this one is what? 59. And not people will see 59 again because we'll spend more than 1 seconds here. Let's refresh the page. Where is the 59? Are we seeing 59? That's gone. Why? Because after every 12 seconds, a new block is what? Created on Ethereum. For Ethereum, because the emphasis is for this section is on Ethereum. Are we together, guys? So look at it. Let's take out a given block. So this is kind of like a reference of what I did here. We have block 0, block 1, block 2. All of them appending to each other. Like a new block is created to append here. A new one like that. After 12 seconds like that. Are we together? So this one attaches itself to this one like that, like that, like that. So now let's take out this block. Open this block. Another opportunity for us to see what is happening here. Can somebody tell me what did you observe here? Tell me what your observation. This is not calculation. We are not writing the database. I'm not writing code. Just observation. Observe. Thank you.
Transactions that I decide to block.
Thank you. I'm just saying. So giving credence to what I depicted here, right? If we take out a given block, we'll see that it compares what? Transactions. Each transaction is a what? A record. Like that. So let's go. This block contains how many transactions? We're going to learn about this one transaction stability. Note this. And what? This is also a transaction. 16 what? Withdrawals. Withdrawals is validators who have staked that to it. They want to what? Withdraw their stake. 16 different validators in the network will queue their what? Their text to it. Let's go here and click it. Before let's click this.
How often do validators withdraw their execution?
No.
How often do they withdraw their execution?
So now for every validator in Ethereum, you must take what? You must run a node. You must run a full node, and while running a full node, you must have take what? Has to eat. That qualifies you to be what? A validator on Ethereum. So what's a validator doing? A validator is going to be what? Standing as a watchman to run Ethereum node 1, to also what? Propose blocks. Because remember, when you say a transaction, the transaction is not immediately added to a block. No. The transaction is where held in a what? A name pool. That name pool is a what? A temporary working area that, let's say all of us are running validator nodes, right? We've taken that to it, we're running a full node. Let me show us what a node is. So we have it now. This is an instance of the node. This is an internal node. It's running, but I disconnected it for this class. I just wanted to show you how it works. This is a node, right? What's a node? A node is a what? A computer. What's a computer? A computer is a what? A machine that has what? Storage, memory, and what? Processing unit. Simple enough. This is it. A simple instance of the what? A node. It's a machine. We will recommend this kind of machine, right? Run a node. So why will we run a node? We run a node because we want to perspective centralized nature of the world of the network. Without running a node, you're not decentralized. Your MetaMask, I'm sorry, they say it's decentralized. It's not what? Centralized. It is relying on a third-party service called what? Insurance that is powering that what? Wallet. If the Nigerian government shuts down access to what? Insurance, nobody can use what? MetaMask again. So you need this kind of machine to truly say that you're part of the what? Centralized what? Network. You're running your own infra. We're going to have a space coming up, have the benefits of running this node. With this node, nobody can shut you down. This is what we call the peer-to-peer network. My node will talk to her node. Her node will talk to your node, your machines. Everybody in the world, as far as we're running the same clients. Does that make sense? Hello. So what's the question? No, not the validator. Running a node does not mean you are a validator. A validator is what? Running this node plus what? Having state what? 32 hits. And running a what? So in my terminal, I'm going to run 2 things. 3 things actually to become a validator. I'm taking out of scrap, but anyway, I'm happy to discuss it. I don't know about it, sorry. I don't know of DevOps, node, infra, and I'm very happy about it. So yeah, so let's talk about it. Now, full node, what's a full node? A full node is that you're running what? Execution clients and what? Consensus clients. This is a full node, right? A full node is what? Execution client and what? Consensus clients. So we have different instances of execution clients. We have so many of them. We have get, we have what? No, get. Go Ethereum. It's written in Go. We have what? Red. It's written in what? Rust. We have what? Eragon. Written in what? Go. We have what? Metamind. Written in what? .NET, C#, right? Then on the other hand, on the consensus layer, we have different ones. We have Lighthouse. We have what? We have Nimbus. We have what? Prism. We have what? Lodestar. So Lighthouse is written in what? In Rust. Nimbus is written in Nim. Prism is written in what? Go. Lodestar is written in what? TypeScript. All of these things, if you run any one of them, I can run get and Lighthouse and run the full node. I can run write and what? Lighthouse and run the full node. So one instance of this, one instance of that, automatically the one running the one, a full node. So this is a computer. This computer is not a node yet. What makes it a node? It is a node when it's running what? An internal what? Client. Right? On this case, execution client. So on a given terminal, you're running execution client. On another terminal, you're running what? Consensus client. That is a full what? Node. And all of them are what? Synced. You are downloading all the history of what has happened on Ethereum to your machine. Right? So whenever you want to send out nobody will censor me. With this, no government will shut down me. They can't shut me down. I'm running an Ethereum node. This is when I can say I'm running what? An Ethereum node. When I'm running a what? The execution client and what? A consensus client. That is when I'm running a what? A full node. Then what makes me a validator? When I'm running a full node plus when I pay what, subscribe it on this, on an account, right? I have the privacy of that account in my validator what client. So full node is what? A validator is what? Full node or not validator what? Clients. So if you already have validator clients, you are what? You're going to what? Propose blocks. You're going to what? Attach the blocks. So what is a proposal? You are going to go to the name pool. It can be randomly selected to what? Aggregate transactions to form a what? A block. You cannot do that without running a node. And without running a what? A validator client had big stake what? At the 2 meters. Does that make sense? Is it clear? That's what you are together. So that's how it works. So somebody asked another question. The other asked. Thank you. There's no room. You cannot just come and say you want to bypass the cheats like INEG and carry transactions and put. You know go work. So let me give you an instance. Whether we like it or not, people are flying now. Do we have access to that data? Do we have access as you are engaged from learning? Do you have access to that data? Radio Nigeria is working. Do you have access to what is being broadcasted? Thank you. You must tune in. There's a frequency, right? On your radio, you tune in 93 point something, 105.2. If you're not on that frequency, you don't know what is what happening. True of us. In the same way, in your Ethereum, he asked the question, come again, ask it again so that all of us will relate to what I'm saying. He said, how do you vet? Thank you. Participation in this network will mean you have what? You have a machine, you have storage, you have memory. True or false? You have Starlink or not MTN or cut off. You have stable what? Internet. Not that when they select as a proposal, you are offline. They will slash it. They will slash it. Right? So you must run all these things. And all of this software have their what? Their rules. The implementing over what? For execution client, there's what called what? Ethereum what? Execution specs. The consensus client has what called what? Consensus what? Specs. These two meet. You cannot just come and check it. There's something like it's obeying. Right? If it's obeying those rules, and there's a validator client making sure that if you're going to propose, you're not going to propose rubbish. If you propose anything that is not right, they will cut you. Other people will check what I propose. They will check. Okay. Is it correct? If it's not correct, they will flash you. Does that make sense? Yeah, so that's how the place is. Otherwise, everybody can just be saying anything and the next of you will come with us. There's penalty for wrong addition of data on the network. So the validators, they know, yes. Not physically, but every they have their IDs. You have this when you have a situation, they're taking me off. But I love to talk about this thing more than anything, honestly. Like you make it to a SSH to a machine and show you what is happening, but I will not do that because of time. Right? Let's focus on what we are doing here. I think on Monday we're going to have a space. On Thursdays too. Going forward, we're going to be having dedicated sessions for us to talk about what protocol engineering, all of the infra things, all of these things are happening real time. So that we go and how we inform decision. We see the laws, we see all of those things happening. So that we're not just talking from a place of what theory. We're talking from a place of what practical what? Yeah, so that's it. Does that make sense? Hands-on practicals, all of this is fun, it's so addictive. If you start running this thing, man, I don't think you eat. Sometimes I don't do anything, I'm just there, and I love it, it's so sweet. I'm sorry. It's one of the things that I've never seen anything that excited me so much like testing smart contracts and running nodes. Yeah, I love this thing so much. Yeah. That big thing. So some people are like, I don't do it for fun, honestly. I don't do it for fun. I just love learning, I love researching, I love what's happening. Peter Nick is talking, I know what he's saying because it makes sense to me because I'm learning it. You're kind of like not really in the inner kind of like circle of knowledge distribution when you don't understand. You are there, you are saying, if you want to get lost and get lost so fast, follow Peter Nick, the follow Ethereum. You don't understand anything he's saying. Yes. But if you're running these nodes, you're kind of like making sense of what they are talking about. You don't know what else. They're trying to like make a change to the consensus clients. And this will take things that like you understand. Like all of these things will make sense to you. Oh yeah, this is it. All of these things will make sense. Honestly, it's a very fun place to be, but it's very expensive, honestly. To run a node, you need so much money because the disk you need, minimum of 2 terabytes, XSD, you have to import from AWA, Amazon cheap, and that's around $200 to $250. For disk, just disk, they're not talking about the machine, they're talking about monthly power supply. You have the stable solar panel that is working, and you have one installing. All of these things is expensive. There's no incentive, honest. It's just passion, honestly, for me, right? Yeah. But that is it, basically. Does that make sense, guys?
Sure. What time on Thursday?
On Thursdays, by 2 p.m., 2 p.m. come around, we'll have it. I think for the past couple of weeks, because we're trying to wrap up our everything, I'm not sure but going forward, it's going to be fun. We're going to set it up. All of the people that have been, one of the guys coming around, he's part of the development population now. He got admitted. The applied and he got in. So these are the things, if you learn about it, you can police your ideas on how to understand it better. Anyways, that is all we're doing. We're talking about data analytics. Right? So that we're not, if you're talking about something, you want to go there. No, our focus is just introducing blockchain for what? Data analytics, so that we know the basics. So in your head, whenever I see node, nobody should what? Bamboozle you. You know that it's a physical machine running the what? The Ethereum client. Execution client, consensus client, running on this machine, right? Then if you want to run a validator, that means you want to propose blocks. You must run what? Full node and have step what? Can do it. And you run an instance of the what? A validator client. A code terminal. That should be managing your attestations. So, yeah. So as a validator, you're proposing block, and you're also what? Attesting to other proposed block or other validators. So if a validator creates a block, you will go and vet. See true. If it's not true, that validator will be what? Slashed. And you can also run a slasher. You can actually be checking who are the people doing malicious things. You'll be slashing them. As exactly you get more reward, actually. Yeah. So it's fun. It's fun, honestly. Seeing all of this.
So we have validators, and validators are validating other validators.
Yeah.
So how, like, okay, now, like, now, we are all humans. And
So yeah, so you can create, so let's it. Somebody asked the question, how are we vetting the nodes? So if these systems are not there, people will get it. If you're going to be there, being honest, any validator we work will slash you. Economic incentive will be lost. So you're running this node to make money. All these validators, when they validate, they aim on token it. But I'm not really a validator node because I don't have to do it. But I run it on testnet. I have to do it on testnet. And I just run it and understand how it works. So that on mainnet, same thing, just to take the environment and pay higher value of what? Ether. Really, that's 30 Ethers. What's the price of Ether there? Calculate. 2,500 times 132. Calculating in dollars. I'm not the mass. So you understand better. Over almost $100,000, right? Am I correct? 80 to 100,000 around that. If you calculate it now, $2,500 for 1 Ether. In millions in Nigerian naira. Anyways, that is it, right? So I'm doing this on testnet. I'm a validator on Sequoia. I'm on Holispi. I'm testing it out so that I understand how it works. But on mainnet, I'm just running a full node. So if I want to send transactions, I don't rely on MetaMask. I can just copy my RPC URL, come to my terminal. From my terminal, I'm not doing it on MetaMask. And before you start from my terminal, I send transactions to anybody. From my terminal, I'm not going to MetaMask to be copying money. And through Ethereum. Why? I'm doing it because I believe in the power of what? Decentralized infra. There's no decentralization without the one good. Yeah. So all those things that you're saying, MetaMask is not decentralized. It's a what? A file. You know, you don't alive. Thank you. All the wallets you're using, MetaMask, Trust Wallet, all of them. If Nigerian government plans access to their what's it called, to their server, they block everybody's IP from accessing it. They did it one time now, Twitter, right? Nobody using VPN to access Twitter. Then I can wake up one day and say, you know what? All these blockchain companies, they've done it already for Binance, but they did it specially because I don't want to, right? You can actually access Binance from your app, but go to URL, Binance.com, it does not work because they sanctioned it. They're not good there, right? If they woke up tomorrow and want to be serious about blockchain and censorship, they will ban every access to Meta. And MetaMask will not even open, let alone loading the wallet. Does that make sense? So now, that power of running a node is what makes Ethereum accessible. I have downloaded the set of Ethereum on my machine. I can perform transactions on this machine. So that's how it goes. It's so much fun. Guys, are we having fun? Yes, our time is up, right? It's four already. So what we're going to do, we're going to continue. But I'm going to give an assignment. All of us, go to MetaMask, download what? We call what? Download the what? The wallet. So the first assignment, right? This is an assignment. We're going to end on this note. And I'm going to share the resources on the Telegram, right? All the things I've covered, so you can actually do further readings. So please be patient with me. Before the end of this evening, I'll send it across. The assignment is what? Go to metamask.io, please, and please. Make sure it's what? Metamask.io. This is the URL. There are a lot of malicious what? Fake websites that is mimicking what? MetaMask. Make sure it's what? Metamask.io. In crypto, there are a lot of scammers. First of all, be very, 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 very careful. Before you click any link, make sure it's the intended link you want to click. Otherwise, they can actually kind of like you're visiting a malicious website and you're installing something that is not real. And instead of you doing the other way around, any money you put in that wallet, they will drain it. So you don't want to be in that position, right? So please, MetaMask.io, download your wallet, then save your new money phrase, then I will give you some. All of us on the Telegram group, all of us are there. We're not there, right? I will send a text token to somebody, right? And that person will go to you. So on the page, for text purposes, so don't use it for main wallet. Don't destroy your main wallet for text. All of us place our wallet address on the Telegram group. So we're going to send testnet it so they can actually use it to check transaction. So all of us will send to each other. 0.00005. 4 zeros and 5, right, to your peer, so that you can actually see that transaction on the block as well, like it has kind of all of these things I will block them. I would together, guys. That's what the assignment. Just do it. Document your findings when you transact. Talk about your findings, right? Use a tool called what? HackMD. HackMD.io. Talk about what you discovered in that transaction. What happens? Just the observation, right? Go to HackMD, see what happened in that transaction, and that is all. Does that make sense? So yeah, I think with that, we've come to the end of the class. So we're going to meet same time next week, and we're going to continue discussions on the Telegram group, right? Oh, we have one. We have one, right? So please, let's continue, and then we're going to catch up next week. Thank you so much, guys. If you have questions, feel free to drop them on Discord for those of us training us virtually.
Thank you very much. Thank you very much, Sadiq. We really appreciate what you shared with us today, and I'm sure a lot of us learned a lot actually. So please share it across your social media, and I think and tag Dun Africa. Yeah, the recording is going to be shared to the Dun Africa Telegram group. So it's going to be shared. So thank you very much. Please screenshot and share across your social media. Let everybody know that you're attending Dun Africa Bootcamp. So thank you very much. And I hope to see you guys next week. So GM.